All right, this is more terrible ideas for containers, the ideal and the real Linux container if you're in the wrong room. But it's always fun to be first presentation in the morning, work through AV problems. So thanks for joining me. So I'm a longtime Linux and open source contributor, now a developer at Puppet, working on Project BlueShift, which is the intersection between Puppet, which is the open source configuration management tool. I don't know if you're familiar or not. The intersection of that with the container ecosystem. So, Docker, Kubernetes, everything in that container ecosystem. A pretty broad spectrum of technologies we work with. This talk only has pretty loose connection to BlueShift. If you want to know more about BlueShift, come to me after the talk. So just quick survey, if you don't mind, maybe raise a hand if you're using containers, either in your day job or just kind of dabbling. Yeah, good number. What about container orchestrators like Kubernetes, Mesos, Swarm? Yeah. I think dabbling is absolutely acceptable. And what about who's using containers in production environments? Oh, great! Wow. Seems like every time we do that survey, there's more and more hands up. I think just a mass of people moving towards containers or looking at containers, dabbling with containers, just to see if that's solves their problems. So yeah, really, I think an explosion in interest in containers. Pretty bold claims, though, I think at this point. I think very similar to early claims about VMs. When VMs were new, they were going to solve all problems, but I think if we look back a little bit, VMs haven't solved every problem. In fact, they've introduced thorny problems of their own. So I expect containers as they mature to do very much the same thing. So great technology, but as they mature, especially as they appear in real live production environments, I think that hype is being tempered with time. So we're going to talk about two promising areas for Linux containers, and then look at containers in the real world. Some data and surveys I've done, and see if they really deliver on those promises. Spoiler: there are issues. Containers don't solve everything, and we'll look at a couple areas where they fall short in real life. We'll also talk about some short-term and longer-term fixes. But I think honestly, containers are still maturing. There's lots of problems that aren't addressed today, and I think those solutions will evolve along with the technology. So I think of all the the problems addressed by containers, dependencies seem to be really at the forefront of the discussion. And I think with any large, complex application or service, dependencies really pile up quickly. You add in libraries, packages, language-specific tools, things like that. Really accumulate quickly. And I think we know that at Puppet. On the right side here, it's an eye chart, but this is all the components integrated into Puppet, the open source management tool. And this is just the client side. And there's some pretty big items in here. If you squint, there's things like Boost, pretty substantial libraries and components that we integrate all. And this is just for the client side. The list for server is much longer. So dependencies pile up quickly, and I think that's like any rich, diverse software ecosystem. Linux is deeply infected with this problem. This is not a Windows only problem, or Sun OS or what have you. Linux is really deeply infected with this dependency problem, and I think that's because with open source software, there's just so much great software out there to choose from. It's very easy to grab libraries and kind of piece things together really quickly with open source. And it's not just OS packages and libraries. It's application packages. Ruby has gems. Python has similar. Of course, Java has jars, and these things, really quickly accumulate. And today there's a bunch of solutions, kind of point solutions for this dependency problem. For Ruby we have RBM, RM, which creates separate isolated environments for your Ruby gems. But these are really point solutions, language specific, sometimes application specific. So the real promise of containers is to kind of do away with a lot of those point solutions and allow you to package up your application with all its dependencies inside that container, distribute it as all together, and then run it well alongside other containers. So that's the big promise, or one of the big promises of containers. I think the other one is containers coupled with an orchestrator like Kubernetes allow you to build these distributed, highly scalable, highly available systems. You can think of the orchestrator like, or one of its jobs as like an OS scheduler, just efficiently packing containers into nodes on the cluster and honoring resource constraints. So very much like an OS scheduler. Orchestrator does things in addition to that, but that's one function. The reason orchestrators can do that in part is because it views containers or pods as a black box that it can just schedule at will throughout the cluster, within constraints. So containers really abstract away that the messy interior of your container, allowing things like orchestrators to have a nice consistent homogeneous API and schedule things around across a large cluster. So if things are going well, you get massive scalability out of containers and orchestrators. The reality might differ, as we'll dig in. So I think there are a lot of published container best practices, some conflicting information out there, but there's some common themes. You should build a compact container image with a lightweight, single-purpose application or service inside. Ideally that container is compatible with immutable infrastructure. So if you make the root file system read-only, things don't blow up. You use things like volumes to contain persistent data. So Alpine Linux, I don't know if you're familiar with Alpine Linux, but it's a lightweight Linux distribution based on BusyBox. It has a shell, has a package manager, has 300 or more command line tools, and there's a container image based on Alpine. It's available on Docker Hub, available elsewhere. So this is probably what we think of as like the ideal starting point for a Linux container. It's 4 megabytes, has just a single container layer, an image layer, only 11 packages, but in those 11 packages it packs a lot, BusyBox and such. So quite a lot in there, and that's this, if you were going to build a microservice from scratch, this might be the ideal starting point. So Alpine is probably the ideal, but this is a better representation of containers in actual use today. Here's some common base container images, alongside Alpine. Alpine's on the left there, and these heavier weights images are to the right. So by and large, those larger images contain an entire OS file system, many packages and files, and the image itself is like 50 times larger than Alpine. And that's kind of what you expect, when you start from a container image called Debian. You expect it to contain, a fairly fully fleshed OS and Debian distribution. But that may not be the right starting point if you're going to build a scalable system with containers. And some of these containers are just truly massive. This is that huge bar there is Go. It's around 700 megabytes in size, and that's build tooling. Probably not something you're going to ship with your app, but things grow very quickly in containers, and you get to these 1 gigabytes images much quicker than you would expect. And all this is before you add any of your actual application or service code to the container. This is just the starting point, and things only grow from there. So yeah, concerning starting points. Just some background for those of you who don't know. Containers consist of a thin read-write layer above one or more read-only layers. And then the benefit is you share. So for common containers, you share those layers across multiple running containers. The problem is it's kind of highlighted here by Fedora. So if we step back in time to VMs, the first thing most people do when they spin up a VM is update the packages. You do a yum update or apt-get update. And that's important, so you get latest version if there's vulnerabilities, things like that. Especially quickly moving libraries like OpenSSL. You want those. You want the latest and greatest. So if you take that, best practices from VMs and you translate it to containers, this is what you get. So you get these, huge blow-ups in your image size. And it's because you have this thin read-write layer over multiple read-only layers. So it's very easy to grow things. It's very hard to prune them away and trim them down. So Fedora, we did an update, and it basically doubled the image size because it's updating all those packages. It actually only added a single package, but it's the updates for all the in-place packages, which kind of kill you, And this may be an extreme outlier, but it's something to be mindful if you're building and working in containers. I think if you search the internet, you'll find lots of interesting analyses of container images. Lots of people are dabbling in this space. This one on the left, I think, is a particularly good study. It's interesting. They took Google BigQuery and then queried all of GitHub, all the Docker files stored in public GitHub repositories. So I think pretty clever, and they suss out some data about what people are actually doing, what base images they're building from, and some other interesting facts based on that. So if you haven't taken a look at this, it's pretty interesting. I think there's about 330,000 public repositories on GitHub with Docker files embedded in them that this surveys against. So I've taken a slightly different approach, taking just an off-the-shelf open source container scanning tool called Anchor. Anchor allows you to scan local images, supports lots of different Linux distributions within the container. Outputs really just a wealth of data. And I think one interesting feature is it allows you to list how many files or which files are not managed by a package manager, which is pretty interesting. What's in there that's not currently managed. This is a pretty cool tool. You can pull it now from GitHub and start using it. So this is just a quick, completely non-scientific sampling of base container images. Same list I showed in the last slide. But I mean, what you see is this compact Alpine on the left again versus some of the popular base images, and it's about an order of magnitude more files contained in there. Really, just an astonishing number of unmanaged files in some of these containers. So where do those unmanaged files come from? It's very image and container specific. But if you're not aware of what's in there, things are going to fall apart. So there's about, I think, 570,000 public Docker Hub repos, and we've done a survey of those. Docker provides like a really nice REST API you can use to query statistics on the the public images, get things like the number of Docker pulls to that image, and from that we know like the vast majority of hub repos are not ever really even used. Basically 99% or more of pulls go to just like 2% of what's up on hub, which I thought was kind of interesting and surprising. So I've taken Anchor and then applied it to like many of that top 2%, examining like every image tagged latest across 5,000 different repos, which I think is a pretty huge and representative sample of like real container usage on hub. You can question whether hub is representative. That's certainly only public repos, but there's a lot going on hub. It seemed like a good place to look. So in this there's 136 official images, and then like 5,000 more that we pulled and then ran Anchor across. Pretty wide range of base container images, things like Debian, base container images, but also services like Nginx. Nginx has, I think, 600 million pulls on Docker Hub, so by far the most dominant container used from Docker Hub. There's also lots of languages and tool containers in here, down to pretty esoteric demos, test images, things like that. Whalesay, which is like the hello world for Docker, is in here as well. So pretty wide-ranging sample, this data is all up on my GitHub page if you want to take a closer look. I feel like the quick analysis we're going to do here is probably losing a lot of detail that are important, but at the high level, if we look at the base container image, each of those 5,000 plus images was built from, we see 2/3 of those are these heavyweight images: Debian, Ubuntu, CentOS, Fedora. So about 2/3 are building from that. Less than 1/3 are building from Alpine, and substantially fewer are building from anything lighter weight than Alpine. There's lots of lighter weight options. There's also Scratch. So a very small number are building from these minimal images. Take a little closer. Here's some median statistics for the lightweight versus the heavyweight. We just picked a median container for both of those. Across these 5,000 images, in which this kind of echoes the data we showed earlier. It's about an order of magnitude larger image, roughly an order of magnitude more packages, files. This was kind of surprised. There's, median, there's really no unmanaged files in those lighter weight containers, whereas there's, 5,000 or more unmanaged files across the heavyweights. So lots, what's inside those 5,000? What are those 5,000 files? What are they doing? Very image specific, but concern if you're building on these things and you have no idea how those files got there and where they come from. So a lot of this is aggregate data. Please take a closer look if you get a chance. So containers are built from, heavyweight images are carrying a lot of baggage, both in terms of megabytes and, that tangle of dependencies that's inside there. If your application has complex dependencies, packaging in a container is a good short-term solution, but probably, thinking to the long term, the full software life cycle, things start to break down. And eventually you do have to confront those dependency problems that you've deferred by using containers. Eventually you want to update libraries to, if you have, OpenSSL is always the poster child, but if you have vulnerabilities, you want to roll those into your containers at some point. Also, you want to get good stuff, presumably, like there's performance optimizations in libraries that you're building on, and you want to get that into your container. So if you defer maintenance by packing everything into containers, your dependencies are out there evolving, and eventually you're going to have to confront that. and hopefully this won't be when like a critical vulnerability comes in, OpenSSL, again, you would really incur all that pain of maintenance right then, while also fighting fires. So the other thing is, if we look at even some of the lightweight container-based images like Alpine, they're really nearly always vulnerable. There's some vulnerability packed into those general-purpose images. This is showing from Docker Hub. There's similar dashboards on Quay and all the container repositories that have scanning built in. So yeah, even really the model container is regularly vulnerable, and so you have to at some point you get caught in the cycle of you're always vulnerable, always updating your containers, always rebuilding things, and this this is somewhat a symptom of just not understanding the dependencies inside your container. So containers are black boxes today, and that can be good, as we talked about earlier, for orchestration. But that's also a problem, and many before me realized this is a problem. And there've been some solutions that others have proposed. You can use container labels to basically document all the components inside your container. Labels are bound to the container image, which is nice, so they travel along with it, and they can be you can examine it externally without digging into the guts of the container. People also proposed embedding the Docker file just in the container itself, so that's you have some documentation for how to actually build the container. That's not default, and that conceivably could also allow you to reproducibly build that container again using the Docker file that's embedded in it. So great ideas, but they fall short for a lot of reasons. One, there's no standards today. There's people certainly talking about standards, but there's no standard place for what you label, where, what format that data is in. Labels are really only key value pairs. So how's the data structured within there? No standards across, the container ecosystem. None of this is built into the tooling. So none of this is automatic. This is kind of a manual thing you have to build into Docker files or your tooling around that. And the other problem is things fall quickly out of date, especially with labels. Labels are inherited by all children. If you build a container and then build other containers from that, it inherits labels, and unless you explicitly remove or update those labels, those are inherited all the way down the line. CentOS has done a really good job of adding labels to their base container image, but there was recently a study where they looked at everyone who was building, I think again on like GitHub, everyone who is building on top of CentOS, and no one is updating those labels. And when they looked inside those containers, the labels were really irrelevant to the data inside. So unless you have the discipline to update those labels or remove them, labels, even a nice Band-Aid like that, is quickly irrelevant. So I think really a better solution is to use container scanners, so at least you automate. It's not a manual process anymore. I showed Anchor data. There's lots of options for container image scanning, including Anchor and plenty of other open source options. There's also hosted services and quite a few scanners just built into public repositories. Docker Hub does this automatically. Quay does this. Increasingly, it's just built into the registry themselves. So what that is, that's really around scanning the image. What this doesn't do, or what a lot of these options don't do, is scan the live container. So you don't know what, once a container is actually running, what is actually running inside that container. Pretty much every container does some setup or initialization. but you're probably more interested in what happens like after that setup and initialization, like what, who's actually listening on network ports, what's actually running, and for that you need, live container scanning. So important questions, you should be asking about your containers, but pretty few options. There's a few options out there today, but not a whole lot. Hopefully the container ecosystem catches up with this live scanning. Okay, small detour, a little bit of editorializing, but how do apps and services, how do they get so complex, especially with open source software? Why do they need to run in these heavyweight container images? I don't think it's just laziness that so many people are using these heavyweight container images. It's because they really need everything that goes in there. This complex mix of libraries and things like that. So this is my estimation why we're here. Your opinion may differ, but I think for greenfield work, a lot of it's when you're building fast, dependencies just pile up quickly. Open source is everywhere, and it's just so easy to stitch together these libraries. And libraries beget more libraries. Libraries depend and build on other libraries. So I think this is the greatness of open source, but it's also an Achilles heel, especially when you're trying to create manageable containers based on open source. So that's the greenfield story. I think for brownfield, breaking down these large monolithic applications and fitting them in containers is just really hard to do. It's much more difficult than it seems on a whiteboard to find seams in these large monolithic apps and actually split things apart. I think the goal is admirable, to decompose the monolith and create a big distributed scalable system, but it's very hard in practice. I think what you often end up with is a few microservices in containers sprinkled around this 5 gigabytes or maybe larger container running really the bulk of your monolithic app, just partially decomposed. So I think I think we should avoid that if possible, or treat it as a baby step to a longer term vision of how to use containers. So just humble advice. Let's not forget engineering and software engineering. You don't need to build slowly. I don't think that's the right answer to fast delivery, but carefully and thoughtfully. Scratch is an empty container image, but that's probably not a realistic option for many who need libraries and things like that. So Alpine is probably a better, I've been harping on this, but Alpine is probably a better starting point for a lot of folks. It has a package manager, so you can observe and manage dependencies. And I think this is Alpine or something like it is much better than I think the Go ecosystem has been going more towards just building binaries and dropping them in containers, static binaries, which I think is a pragmatic, short-term solution, but it's probably not the right long-term approach. As vulnerabilities, things like that you're building on, you don't want those embedded in just a single binary in a container. That's probably not the right choice. You'd rather have a package manager so you can observe dependencies, observe things at runtime. So this might seem obvious, but just design your containers for a single purpose. Don't pack everything into one of these 5 gigabyte container images. It's very tempting. I see it all the time. We're building lots of Jenkins pipelines using containers now. And we have this 10 gigabytes universal image that does everything, has every tool for every possible thing we build. And that's just, that's a sad use of containers. Hopefully with time we break those down into, containers for each particular purpose. And I understand, from ops side, it's much easier to build a single container image and validate that and have that work across, everything. But it really breaks the, container and microservices and distributed, a scalable system model. And I think that's that's a habit probably formed back in the VM days, where you build this golden VM. And that was acceptable then, but I think it becomes even less acceptable, and just causes huge efficiency problems when you try to do that with containers. I guess the other downside is, though, you need with containers, even more so than with VMs, you need a fully automated CI/CD system. If you're building all these container images, you really need that to be automated. That can't be a manual process, not forever. And this is 2017, so people should really get with it with CI/CD. It's been available for a long time. Jenkins is out there and free, so hopefully with containers, more and more people move to one of these fully automated systems. I think more broadly, I think just understanding your dependencies, what you're packing into those containers, and questioning these over time. A lot of people have these prototypes that suddenly grow and then are a product at some point. But I think it's important to be willing to go back and refactor and redesign, cut away some of that fat when they go from prototype to product. Even that's probably a good amount of effort, but worth it, I think, for the long term. Maintainability, we've been kind of harping on that, but I think knowing those dependencies in the container is going to allow you to, when you do have a maintenance cycle, to quickly and efficiently roll libraries and dependencies and things like that. So plan for maintenance, use automated tools to identify dependency creep. I think dependencies quickly accumulate, and almost without any effort. So if you have automated tools to detect the set of dependencies you're building into your containers, I think that takes you a long way to understanding and keeping tabs. Just general, I think. Let's not forget engineering. It's kind of hard work. It's not always very rewarding, but I think keeping a close eye on dependencies is the only way that containers are going to work, efficiently long term, especially in production environments. Cool. That's all the slides I had. I actually thought I only had 40 minutes with questions. I have a little longer. Lots of great talks here. Here's some other talks around containers that I thought were interesting, roughly in order of time. Lots of other talks with no relationship to containers that I'm really excited about. There's I think roughly 10 time slots for sessions. Thanks so much for spending 1/10 of the conference with me. All right. Any questions? We've got plenty of time, I think. Probably too much time.
How do you develop a knowledge around reviewing somebody else's container? For example, I look at node containers on Docker Hub, and there's 30 choices. Some are based on Alpine, some are based on others. How would I go about evaluating what a right choice is?
A scanning tool like Anchor is nice for kind of breaking that open and seeing that you can get a complete list of every package that's in there, every file at whatever level of granularity you want. So I think that's a great start. That'll also give you ties to active CVs, things like that. Lots of open source tools, but yeah, check out Anchor for sure.
So you seem to know what you're doing. Just before I go to one of these other talks, I've seen 2 of these Postgres and Docker talks, and that scares the crap out of me. Should it?
Whether databases make sense in containers, is that the question? That's broader than I can answer. There are lots of people doing it today, but there's also lots of people, I think, if they want real performance, they have a backend, a non-containerized database. So these hybrid approaches. I think things are moving fast though, so we'll see. But yeah, I would be
too soon to call.
I think it might be too soon to call, but just thinking of
use cases and no one answer.
Yeah, there are. It's very much product specific, but I personally like the hybrid approach. Makes sense. I don't think there's always this, same with VMs, containers, like there's no solves everything approach. I think the reality of future is going to be some hybrid. There'll be like physical infrastructure, there'll be VMs, and there'll be containers all kind of working together, solving problems at different levels. So yeah, I think that applies to back end as well. Any other questions?
Can you expand more on what you were saying about your feelings about like scratch builds with a Go binary or something versus?
Yeah, I mean, so I think it's great for creating one single lightweight container. Once that's out in production, though, you tend to lose sight of what's inside of there. So if you do have a single, Go binary running inside a container, later in time when you're experiencing problems, scalability problems, concern about vulnerabilities, how do you know what's inside that container? Maybe you do one of these Band-Aid approaches, apply labels to describe exactly what was built into that Go image. Maybe you embed some artifacts about your Go build in the containers to document it. But there's no standard way to do any of that. There's also no tooling to crack open, a Go binary inside a container and figure out, what that's building on, what version of, SSL, and all the other dependencies are in there. So that's kind of concerning. There was this, a long time ago, everything was statically built, and then we moved to dynamic libraries. In a lot of ways, we're, pushed with Go and, containers in general is to go back to the binary model, to static binaries model. And I think that's a little bit broken. I think we should benefit from knowing and understanding those shared dependencies.
So what would be your take on like the BusyBox still use glibc approach?
Or whether that's acceptable, or you should use something lighter weight, or
well, if we're concerned about being able to crack open the Go binary, we won't know what C libraries were compiled in. Like, would you call it better to be sitting with glibc where it's still dynamically linked and you can still call into it?
Yeah.
In the interest of Go and containers, I guess.
I think any transparency you have to what's inside there is a good thing, and if that's using shared libraries or other mechanisms to better document and have reproducible builds, I think that's a good thing. And to be able to track those.
Git SHA for the image tag, just like not enough?
Yeah. I mean, a Git SHA is not like, or layers, or SHAs, but that's not enough to diagnose like what's actually in there to reproduce it. It's very tough. So unless you have today outside mechanisms, maybe in the future standards around metadata.
I guess I'm not sure what information you're thinking. Like, what can I not get, I guess, if there's the C library versions and what version of the code base I
What about other dependencies? So so you have standard C library version that you can track. What about all the other open source libraries you've integrated?
I assume we're vendoring, and we know exactly at a given Git reversion what dependencies we're using.
How do you so looking at a container image though, where does that information come from all your dependencies? Where do you get those Git SHAs, and how do you decompose things?
It's the one, right? For your code base, for the service that you're deployed, I've committed my changes, and it has its vendor JSON in there, which describes its dependencies. And so this is just a revision for your code base.
Okay.
And it sits there as your little short tag.
I think as long as that's embedded in somewhere, it's trackable, because you're likely handing off your container to someone in production, someone you're throwing over the wall. Someone else has to be able to understand those dependencies and track that down, perhaps long after you've forgotten what you packed in there. I think that's a problem, and that's something that needs to be addressed.
Yeah, we still have to rely on trusting each other.
Yep, people are involved.
So with Alpine being a bit of a younger OS compared to like Debian and some of the more established players, you have a good sense on how well it's maintained and the packages in it are maintained compared to some of the more?
That's a good question. No, I don't think I have. I don't think I've followed Alpine long enough to say. It is relatively new, but it's also built on BusyBox. Has been around for a long time, and most of what's in an Alpine is BusyBox. But yeah, what I don't know is how well maintained, and it's going to be very application specific. Whether Alpine out of the box provides you with the libraries and things you need. Perhaps not. It's certainly a smaller set than you would get with Debian or Fedora or what have you.
That was kind of my concern if I was to try to migrate everything over to Alpine, how robust.
I think Alpine will be continuing to grow, though. Especially, I think it's especially compelling for containers. It's also really compelling for embedded environments. I think it's going to continue to grow and have a richer set of libraries that are available. But yeah, you're right. There may be some growing pains, I think, in the short term.
Maybe analogous to the early years of Ubuntu being built on top of Debian.
Absolutely.
Some of that growing pains.
Absolutely. Okay.
Going back to the Go, Go.
I may have chosen the wrong fight to make here, or wrong statement.
We Go programmers.
I love Go personally. I love building things on Go, but I think there are challenges.
Is there any survey or any information? Is anybody using this for the production? Because actually, this should be just like to use as a to compile your program, and that's all. This is the best idea because I can build that on my Mac, or even someone can build on the Windows.
It's I think the portability, the fact that you can make these really compact containers is awesome. It's that a year down the road when that container is still running, can you reproduce what's inside there to track down problem or to update dependencies? That gets kind of tricky, I think. Maybe there's already solutions that I'm unaware of to really track that, or there's certainly people building real production code on Go have created processes internally, but there's no across the Go ecosystem. I'm not aware of good ways to do this. So, one last question.
You mentioned CI/CD in the context of Docker. Is there a good reference online that would outline like a prototypical implementation of that?
There's lots of just.
What you would recommend?
Gosh, I don't think I'd be able to make a recommendation. But there's so many options. It's a little overwhelming. I think it might be somewhat product specific. What's going to work for you? Okay. Any last one?
Your slides anywhere online? Or?
Yeah, I'm going to post these right after. I tried to post them before the talk, but I'll have them up on the conference site and on SlideShare. Great. Thank you so much.